In this video, we will look at a few dosage calculation problems where nurse must calculate an IV flow rate in milliliters per hour. Let's take a look at our first problem. Administer medication Z at 5 mg per hour IV. Available medication Z 125 mg in 100 milliliters D5W. What is the infusion pump set for in milliliters per hour? Let's see what we can figure out here. 5 mg per hour, that's our order. The question is how many milliliters per hour is that? Let's set it up just like this. 5 mg is X milliliters. Now, what do we know from this problem about milligrams and milliliters? We know that 125 mg is 100 milliliters. We're going to write it down just like that. 125 mg is 100 milliliters. Notice that I carefully placed my milligrams under milligrams, my milliliters under milliliters. If you're calculating hours, they're going to go hours under hours. If you're trying to find ounces, ounce under ounce. So carefully set up your problem where the same goes under the same. Afterwards, we're trying to find diagonal that has two numbers in it. This diagonal here has X and a number. We can't use it. This diagonal here has two numbers that we can use for calculations. We're going to multiply these two numbers, and we're going to divide by this third number. So in this case, X equals 5 times 100 divided by 125. And that equals to 4 milliliters. And we know we got milliliters because we set our X under milliliters, and that is our answer. Here's our next problem. The order is to administer 100 milliliters of normal saline to infuse over 45 minutes via IV pump. Now remember, our pumps understand only milliliters an hour, and it's nurse's job to program the pump to administer the exact amount of the ordered medication. So what will the nurse set on the pump in milliliters an hour? And we're going to round our calculations to the whole number. Let's see how we can set it up using our DKP method. 100 milliliters are going over 45 minutes. And we need to find how many milliliters are going to go over an hour. We're going to write it down just like that. 100 milliliters is 45 minutes. This is my is line. Remember, it's not equals necessarily because milliliters don't equal to any minutes. But 100 milliliters is going over 45 minutes. Now, I need to find per hour. X milliliters is, however, I can't put 1 hour here because I have to have milliliters under milliliters, minutes under minutes, hours under hours, milligram under milligram. Remember, the same measure goes under the same measure. So I'm going to quickly convert my hour to 60 minutes. And now it's all set properly. Next step, we're finding a diagonal that has two numbers in it. And you know that it's not always going to be diagonal that's facing this way. It can be this one. It depends where you put your X. I'm going to multiply these two numbers, and I'm going to divide by the third number. $100 times 60 divided by 45. And on your calculators, you will get the number 133.333 repeated. After rounding to the whole number, we get 133 milliliters. And that's our answer. In 60 minutes, we will be infusing 133 milliliters. So 133 milliliters per hour is the infusion pump going to be set for. In this problem, the order is to infuse 1000 milliliters of normal saline over 8 hours. Calculate flow rate in milliliters per hour. So let's set it up just like we always do using DKP method. 1000 milliliters are going over 8 hours. Is 8 hours. 1000 ml is 8 hours. We need to find how many milliliters per hour, per 1 hour. X milliliters is 1 hour. Here we don't need to convert our hours to minutes because we have hours under hours already. Milliliters under milliliters, double check yourselves. And now we're finding a diagonal that has two numbers. There it is. We're going to multiply these two numbers and divide by the third one. X equals 1000 times 1 divided by 8. 1000 times 1 is just 1000 divided by 8 gives us 125 milliliters, and that's milliliters in 1 hour. In this problem, we are ordered to infuse 1 liter of D5W at 125 milliliters an hour. The question is, how long will the infusion last? Let's take a look. What do we know? We know that 125 milliliters are going over 1 hour. And 1 liter, we don't know how many hours. Let's set it up just like that using DKP method. $125 milliliters is 1 hour. 1 liter is X hours. However, I can't use liter here. I need to convert to milliliters so it will match my measurements here. And I know that 1 liter is 1000 milliliters. So 125 milliliters is 1 hour. 1000 milliliters is X hours. Multiply on diagonal, divide by the third number. $1,000 times 1 divided by 125 gives me 8 hours. I know it's hours because I set my X under hours. And that's how long my infusion will last. In this problem, the order is to administer medication Z 0.5 milligram per kilogram per hour for a patient who weighs 50 kilogram. The pharmacy sent IV bag of 50 milligram of this very medication Z in 250 milliliters of D5W. So how many milliliters an hour do we need to set on the IV pump? This is a little more complicated because the order is given in so many milligrams per kilogram per hour. And we need to figure out how much is that for our patient who doesn't weigh 1 kilogram, who weighs 50 kilograms. So using DKP method, we can quickly figure it out. I'm going to say 0.5 milligram is 1 kilogram, is for 1 kilogram of body weight, is for 1 kilogram. My patient weighs 50 kilograms. I'm putting kilogram under kilogram. And I don't know how many milligram that is. 0.5 milligram is for 1 kilogram. And I don't know how many milligram is for my 50 kilogram patient. Let's find X. $0.5 times 50 divided by 1 is 25 milligram. I know I found milligram because I set my X under milligram. I found 25 milligram. That is how many milligram my patient who weighs 50 kilogram will receive per hour. Now we need to figure out what is it in milliliters because the pump needs to be set up in milliliters per hour. From this problem, we need to find what is the concentration of this medication, milligrams and milliliters. How many milligrams per how many milliliters? Let's take a look. Here's pharmacy sent us IV bag of 50 milligram in 250 milliliters. So let's set it up this way. $50 milligram is 250 milliliters. That's what we received from pharmacy. We need to administer 25 milligram. And again, I'm carefully placing my milligram on the milligram, and I'm going to put my milliliters on the milliliters. 50 milligram is 250 milliliters, 25 milligram is X milliliters. And X equals multiplying on diagonal, dividing by the third number. $25 times 250 divided by 50, and that equals to 125 milliliters. And that is milliliters per hour that I will set on my IV pump to deliver that order. You will find many more dosage calculations for practice in my book, Dosage Calculations, Getting It Right Every Time.